Welcome to Easy Math TV. We're going to continue our exploration of descriptive statistics where you have a data set and you wish to describe it, you want to understand it, you want to analyze the patterns, any patterns that emerge in that data. So this time we're going to be comparing two sets of data that you can see here. The first set of data has to do with wait times in minutes of a randomly selected sample of customers at the DMV. The second set of data is wrist sizes. These are in inches for adults in Hillsborough County. Um, I just should put a disclaimer that that's not real data. I've simulated or made it up based on information that has been reported from those places. So our goal today is we're going to use snippets again. And honestly, the reason why I chose that is because it is literally like just so easy to just input your data and um, a few commands later, and you've got everything you need for describing your data. So we're going to use snippets, and so we're going to get all of this that you see here, that you see listed here. We're going to get something called a 5-number summary. And that is, so there's 5 numbers that are reported with that: the minimum value, the first quartile, the median, the third quartile, and the maximum value. So you need those in order to make a box plot, basically. Um, but they're also used for other reasons as well. We're going to calculate the mean. We're going to calculate something called the interquartile range, or IQR, and also the standard deviation. So I should just note that those two things are different types of measures, but they both measure kind of the same thing. They both measure the spread of your data, like how your numbers are spread out. Um, the 5-number summary, the purpose of that is to show whether your data is symmetric or not, and where the big concentration of your data is. So that shows you where your concentration of data is. The mean is one of the other measures of center, or like measures of central tendency that we have. And that goes along with the median. So the median and the mean are both measures of center, or measures of central tendency. And then we're going to make the two usual plots. We're going to make a box plot, and we're going to make a histogram. All right. So every one of those things is going to be created with each of these data sets. Okay, so we're also, at that point, we're going to decide whether the data is symmetrical, shaped, like, so the distribution of it, does it seem to be symmetrical? Does it seem to be centered where we expect it to be centered? And, and the presence of any outliers would tell us that the data is more than likely not symmetrical, it's probably skewed. So we're going to see if there's outliers in our data. Lots of stuff that we're going to be able to see just from typing in these commands that you see down here. So at the bottom of my notepad document, there's basically 6 lines of formulas that we're going to type in. And the first one is going to just create our data set, and we're going to call it my data. So we're going to give the data set a name. It's just called my data. And what you see here is a built-in function. Just like you would see built-in functions in Excel, you see built-in functions in R. This basically, we're using R. Those built-in functions help you to create and work with data. So we need the lowercase letter c, and then a parenthesis, and then we're just going to copy and paste our data inside the parentheses there. And but basically what that does is it just tells R to give our data a name and to store it into this object that we're calling my data. And then we're going to do the 5-number, this is the 5-number summary here, which is also going to give us the mean. So it's going to give us the 5-number summary, and it's going to give us the mean. We're going to calculate the interquartile range. We're going to calculate standard deviation, which is SD parenthesis. And notice that the interquartile range is in capital letters. Again, remember, if you watched my previous video using this particular website, I mentioned that everything that we do is case sensitive. So it's important that when you see lowercase letters, that they remain lowercase letters. If you see capital letters, they need to be capital letters. So we have, we're going to create the data set, calling it my data. We're going to do a summary. We're going to do interquartile range, standard deviation, Boxplot, and histogram, which is HIST, histogram. And you'll notice that for every one of those things, we have the name of our data inside parentheses. So I'm literally just going to copy all of this and paste it into this website. So let's just do that now. So I'm hitting Control C or Command C, and let's move this over briefly. And here's the snippets website, rdrr.io/snippets. And this is what greets you. We're just going to delete all that. And I'm hitting Control V. So my data equals, right? So we need that to be the actual data. So I'm going to delete all that. And now I just have a blank set of parentheses. And let me pull this back over. And we'll start with our DMV data. So let's start with our DMV data. I'm just gonna select it all. And you'll notice that these numbers are separated by commas. That is absolutely necessary. The numbers have to be separated by commas. I'm going to hit Command C again, or Control C, to copy it. And then over here, I'm pasting. So there you can see the numbers appear inside the parentheses with a lowercase letter c in front. That's the lowercase letter c just means to concatenate. That's a fancy word. Concatenate just means basically you're combining all of those numbers into one, what we call a data frame, or a data vector. That's a fancy word. But basically that's just one data set, and we're calling it my data. So underneath that, we see summary my data, we see IQR my data, we see SD my data, Boxplot, and HIST. So I'm just going to click on the Run button here, and I'm just going to scroll down. So as you can see, this is how our data gets presented. This is how everything gets presented to us. We can create, you can actually create an image of this output. But let's just look at all of our numbers. We have our minimum value is 10. So the minimum amount of time that anybody waited at the DMV was 10 minutes. Q1 is 40.25. So that means 25% of people, only 25% of people waited less than 40 minutes at the DMV. Median was 46. So 50% of our data is below 46, and 50% of our data is above 46. The mean was actually 43.47, so there's a little bit of a discrepancy there between the median and the mean. The third quartile was 48.75, and the maximum was 60. So 1 hour was the maximum amount of time that anybody waited. Okay. What else did we ask for? We asked for the interquartile range, which is the number 8.5. So that's basically when you take the third quartile, which is 48.75, and subtract the first quartile, which was 40.25, and we get 8.25 as our interquartile range. And then the last number that we figured out was the standard deviation. So these are our two measures of spread, how spread out the data is. Okay, and then we go down here, and here's our box plot, and you can see that we actually have two outliers in our data. That a huge concentration of numbers are between 40 and 50 minutes. So there's like the lower edge of our box is at 40, that's our quartile 1, and quartile 2 was up here at 48.75. So, you know, half of the data values are within that box, and then the two whiskers are basically taking us out the rest of the majority of our data. And then we have these two outliers down here, and you can actually see how those outliers play into it by looking at the histogram, because in the histogram, the two outliers are represented by those two lower, very, very short bars, and then the taller bars are concentrated between 30, you know, greater than 30 minutes up to 60 minutes. Like that's the big concentration. So you can actually see that the data is skewed if you know what I'm talking about. All right. So that is our DMV data. So now let's do the same thing with our wrist size data. So I'm going to hit Command or Control C to copy it. Go back over here, and we're just going to replace all of that data there with our wrist sizes. And we're just still going to call that my data. So you'll notice that all I did was replace everything that's inside those parentheses there. And it's okay that it went down from this line down to the next line, because R will just keep on reading. And we're going to do the same thing. Summary, IQR, standard deviation, Boxplot, and histogram. Hit run. And lo and behold. So there we have it. We have our minimum. The smallest size was 5.6 inches. The largest was 9.5 inches. And there's our two quartiles, and the median and the mean are very close to each other. That also is a good sign that our data is symmetric, that it's not skewed. We also have our interquartile range is 1.375, and the standard deviation is 1.07925. You'll notice that there's more decimal places in the standard deviation. That just has to do with how that number is calculated, and our box plot is very, very symmetric. There aren't any outliers. The two whiskers are about the same length. The median is right at the center of our box, so the median and the mean are right next to each other. But then the histogram almost looks uniform. So if I were to describe the distribution of this data, I would probably not say that it's normally distributed. I would actually make a case for the fact that it's uniform, that like, you know, the numbers of things in each of these ranges is nearly the same. So this is almost a uniform distribution here. Anyway, so that's comparing two data sets, or, you know, looking at a data set and trying to figure out like what the patterns are, where is the central tendency, is there skewness, is it more symmetric, or is there some skewness in the data? Do you have outliers? You know, there's all kinds of things that we can answer just by looking at these numbers. And they tell us a lot. So like, subscribe, comment down below. If you're enjoying these videos, share them with other people, especially if there's other people taking stats classes and they have to calculate all these things. There are ways to do it that are just very simple and very much easier to do than even using a graphing calculator. So I'll see you in the next video.